Today we'll look at the 1.3 function or not video notes. First thing we're going to talk about are the two words that we'll deal with today, relation and function. A relation is a set of values that can be expressed as a table, a graph, ordered pairs, or a mapping, and we'll talk about those particular things here in just a moment. Then we'll talk about a function. A function is a specialized relation. A function is a relation in which each input has only one output, and I'll show you those examples here in a moment. But basically it means for everything you put in, you only get one output. In other words, if I ask you what 3 plus 4 is, that's an input. I can't give you two different answers. Our first example will be a table. We're going to use the equation x plus 3 equals y, which means we put something in x, we get out an answer. So let's say we put in 0 for x. 0 plus 3 is 3. We put in 0, we get out of 3. We put in 1, 1 plus 3 is 4. So we put in 1, we get out 4. We try that with 2, 2 plus 3 equals 5. So we put in 2, we get out 5. We can do that with a negative number like negative 1. Negative 1 plus 3 is 2. So we put in negative 1, we get out 2. So we have an example of a table that is a function. Next we'll look at ordered pairs. That's when you take the numbers in the table and you write them down in ordered pairs. So we have like negative 1, 2. We have 0, 3, 1, 4, 2, 5, and 3, 6. Notice in each one of them, for every x, there's only one y. And the one way you can check that real quick, we have negative 1, 0, 1, 2, and 3. None of them repeat. Since none of them repeat, this is a function. If we repeated, if I had another ordered pair like 2, 7, then that would be not a function, but this one is, works out just fine. Next we have a graph, and a graph is the easiest way to determine if something is a function. We use what's called a vertical line test, which you may have heard before. It's very simple. You take a vertical line. If at any point and it touches the graph at more than one place, then it's not a function. For example, if I draw vertical lines here, like so, at no point does one of those red lines ever touch the graph more than one place. So this is a function. And if you want to ask about this in class, I'll show you how to do it with your pencil so you don't actually have to draw on your papers. But if none of the lines touch more than one place, then that's a function. And next we have a mapping. If you've never seen a mapping, they can be kind of interesting because it's a nice visual way of seeing all your values, your inputs and outputs. So if we took the same information that we used early on and we list the inputs and outputs in the appropriate circles, we can compare. For example, negative 1 went with 2, 0 went with 3, 1 went with 4, 2 went with 5, 3 went with 6. That's what a mapping is called. Now you'll see an example that doesn't work in a minute, but basically you draw a line connecting the input to the output. And this is an example of a function because none of the inputs are connected to two different outputs. So next, let's look at a couple examples of some non-examples, things that are not functions. Here you can see I have 5 different pairs of numbers. I have 0, 5, 1, 7, 2, 13, 1, 17, 4, and 11. Now, most of that looks okay, but if I ask you if the input is 1, then the output would it be 7 or 17? So that's two different answers, therefore this is not a function. Now here looking at ordered pairs, you can see that we have a set of 5, and we do the same way we do a table. Look, negative 3, 0, 5, 5, 9. These two are the same. We don't know if the input's 5, is the output 2 or 11. But now let's look at a second example here, the one I wrote in black. It's a whole new set here. I have 3, 11, 4, 11, 5, 11, and 6, 11. A lot of us will look at that and go, well, that's obviously not going to be a function because all these 11s. But the key is, does every input, that means the x values, does every input have its own output? In this case it does. Even though the 11s repeat, the y's don't matter. We only look, do the x's repeat? If the x's repeat, then it's not going to be a function. But this is definitely a function. This one is not. Next, we can look at our graph. We'll do the same thing with our vertical line. If we draw a vertical line, see like that one, only touched once. So you may think, okay, we have a function. But as we keep drawing them, we start noticing that several times there are places where it intersects with our graph at more than one place. That proves that this is not a function. Even though in some cases it crosses once, there are places where it crosses more than once, so therefore it's not a function. Here we look at a mapping. Now just by looking at it here, you can't tell one way or the other until we start looking at how they're mapped together. So far so good. Each x only has one y. But as we look at the rest of it, you can see the lines in black show you where that 9 is attached to both the 4, the 5, and the 6. If we wrote out the ordered pairs, we would have something like this: 3, 4, 8, 4, 9, 4, 11, 6, all good, but then 9, 5, and 9, 6. So therefore it is not going to be a function. When the 9s start repeating, no function. So now you see one more table on your paper. Go ahead and fill that one out. This time I want you to create your own. Just give an example of your own. Either pick a function or non-function, label each one function or non-function. It doesn't matter which one you choose, but you come up with an example. If you're not sure if you had it right, check with me in class. I'll be glad to tell you. But in conclusion, the main things you look at is, in most cases when you see numbers in a list of numbers, you look at the x's. If they repeat, if x's repeat, then it's not a function. If they don't repeat, then it's probably good to be a function. If you're looking at a graph, you do the vertical line test. Remember, anytime the vertical line touches or crosses the graph more than once, it's not a function.